So whenever you go to add your PowerPoint, you'll just need to put it like after the first slide. Okay.
We're here, Trevor.
Can somebody say something once more to see if I have my...
You're all set, T. I can hear you.
Oh, I had my volume turned off on the...
The Illuminate sessions, introducing the NC MarketReady Fresh Produce Safety Field to Family curriculum. Today we'll have 3 presenters, and we'll start off with an introduction to using Illuminate. And for this, I'm going to pass it off to Megan Bain, who works with us at the Kannapolis Research Campus. Megan?
Thanks, Diane. Just quickly, if you're unfamiliar with Illuminate, the presentation will be occurring on the whiteboard, which is where the text message is right now. And today, only the moderators will have their microphones enabled, but we encourage everyone to ask questions. And you can do that on the left side of the screen where the chat box is. The line beneath the chat box is where you type your message and choose send to this room. And just so everyone can be aware, we are recording this session, so we hope that you can keep the chat box chatter, per se, to relevant topics for the session, and even though you do have the option to communicate person to person, those comments will appear in the recording. So I think that about covers the etiquette, and if the presenters run into any trouble or if anyone has any issues, if you will type a note in the chat box, I'll try to address those issues. Okay, thanks.
Thank you, Megan. And so right now, I'm going to send a message in the question box so you all can see where it would show up and what Megan was talking about. So you just type that in and then hit return, and it will show up in that box, and it will go to the whole room unless you specify different. We will try to capture these questions and address them at the end of the presentation. So, as I said, this is the introduction to the North Carolina MarketReady Fresh Produce Safety Field to Family curriculum. Some of you have seen this curriculum. Some of you actually have this curriculum, hopefully in your hands in your counties. My name is Diane Ducharme. I work at for NC State and work out at the North Carolina Research Campus in Kannapolis. I'm the GAPS Program Coordinator with the North Carolina MarketReady program. Some of you may notice that you see a name change. We used to be the value-added team, a value-added program, and we are now the NC MarketReady program. So these Illuminate sessions, we've scheduled 4 for this week, starting this week and through next week. The times are indicated on this slide. From 9 to 11, I tried to keep that. The only stray we have is November the 19th, and that's going to be a 1 to 3. This will allow us to have time to go through the curriculum for those of you that have not gone through the curriculum. It will also allow us to have some time to go through the new tiered approach, the branded program, and the website. So it's a little bit more. This morning we've got this whole introduction, so some of you that have gone through the curriculum previously, I suggested you sit through this first morning, this first hour of this morning, so that you have a good overview of what is happening and what has been developed. We cannot forget our funders for this curriculum. It was funded by 3 different granting agencies: the Sustainable Agriculture Research and Education Professional Development Program Grant, the North Carolina Tobacco Trust Fund Commission, and the Risk Management Agency. Without these fundings, we would not be able to do all that we have done with this curriculum. So we are very indebted, and our thanks go out to this funding agency. The other hat that the presenters of this curriculum today wear, along with the NC State hat, they wear co-chair hats of the North Carolina Fresh Produce Safety Task Force. From the left, you'll see in the picture Dr. Trevor Fitzer. Heading to the right is Dr. Benjamin Chapman, myself, and then Dr. Chris Gunter. The curriculum was developed to target the needs of educators as a train-the-trainer program. What that means is during the last year, 2008-2009, we've gone out and trained agents. Right now we have about 94 agents across the state trained in this curriculum. As I mentioned, you all have in your counties, there should be 1 notebook, a hard 3-ring notebook, and also a jump drive of the electronic copies of the curriculum, also the branding program, and a communication kit. The emphasis of this curriculum is on understanding the microbial risks, and this is from beginning of production. So when you're in the field starting out your production, all the way through the distribution of the fresh fruits and vegetables. The curriculum is meant to complement the original guide that was put out by FDA in 1998 to minimize microbial hazards in fresh fruits and vegetables. And also, it's meant to address some of the needs that we were seeing surfacing as we started going through some of the audits and the GAP certification process. The curriculum is a total of 9 modules. The modules are intended to be a 1 to 1.5 hour block of instruction, and you can see the content of these of the curriculum. It is more than just GAPs, as I mentioned before. Kind of the last 2 modules, Module 8 and Module 9, deals with a little bit more in the area of risk and liability and crisis communication. Each module has a PowerPoint presentation and has more in-depth notes and references, along with some experiential exercises and handouts and pre- and post-tests. Now I'd like to pass the baton to my colleague, Dr. Chris Gunter, and he is going to talk about the tiered program that has been developed. Chris?
Thanks, Diane. As Diane mentioned, I'm one of the co-chairs of the Fresh Produce Safety Task Force, and I'm also a vegetable production specialist in the Department of Horticultural Science. I'm going to tell you a little bit about the development of this tiered approach to the educational curriculum. Really, this idea of the tiered approach evolved out of a recognition by the retail industry that some level of training is essential, and that really when they're looking for product, they'd like to buy product from producers that have been trained in the GAPS curriculum. And also the growers who have participated in the development of the curriculum noted that one strategy for training does not fit all growers' needs. So some growers are marketing directly to chain stores which require training, and others are not. So we wanted to make this tiered approach more adaptable to the different needs of those producers. With that in mind, the North Carolina Cooperative Extension faculty and growers developed this tiered approach with the farm size, market needs, and commodity-specific risks sort of incorporated into the program. And if you think about this tiered approach as a pyramid or a triangle, at the bottom of the pyramid is the most basic level of training. And really this was a recognition by producers that every grower needs to be trained. Every grower should have a good understanding of GAPS and a basic level of training in that. With our curriculum that we've developed, the modules serve as the basis for that these training tiers or training levels. The basic tiers are what every grower will go through, and then as their needs as producers increase, then they can move up to the second tier and the third tier. I'll give you just a little bit of background. The first tier is sort of this basic level of training. It contains the first 6 modules. The topics are listed here: Fresh Produce Safety Basics, Pathogen Introduction to Produce, GAPS for the field, GHPs for packing, proper health and hygiene, water quality, and then issues with site selection and manure management. The training is designed to be delivered, those first 6 modules to be delivered in about 7 hours of instruction. We envision this to be through a series of 3 2-hour classes with assigned homework after each session that the grower can take away, do on their own time, and then bring back to the next training session. Our rollout period will be somewhere in the 2008 to 2010 range, and that training will be done by agents who have been trained in the curriculum. The Tier 2 is really a more advanced level of training. It encompasses traceability and risk management, and the content that will be covered includes modules that have already been developed on traceability, transportation, recall, liability and insurance, crisis strategy, and risk management. Again, the delivery of that will be similar. It'll be the modules 7 through 9, delivered through, or in addition to risk identification and management workshops, which are held on farm. This will also be about 7 hours of instruction. The suggested delivery will be a 1-day workshop that's held at least annually, and our vision is to roll that out in the 2010 to 11 time frame. Tier 3 is currently under development. The content will be dependent on the new regulations and requirements that will be handed out by the federal government. We're waiting to see what those regulations will be and then construct Tier 2 around those needs. Our vision is that specialists will deliver this level of training. Also, we'll try to keep it in that 7-hour, one-day workshop format, and our target dates will be somewhere in the 2011-2012 range. This tiered approach really is proactive and incentive-based. It allows growers to move up the pyramid based on their individual farm and needs. A certificate of attendance will be issued to participants so that they can show customers something tangible. We also envision those producers who have been through this tiered approach to have their information linked on a website so that retailers and marketers could search for those farms based on their product need. And I think I'll turn it back over to Diane now to talk about the website.
Thank you, Chris. Okay, so switch gears on you just a little bit. What I wanted to do is share with you the website and what Chris just went through, where this information is. Because we have both agents and I can see at least one grower that I know on this participant list, we wanted to take you through the resources that are on the website, because as you deal with more of your clients and more questions, we're hopeful that the information on this website is going to allow you to answer that information. And if you send me an email or send Chris or any of the co-chairs or any of the other people that are working within the fresh produce area, hopefully they'll be able to reference you back to this website because the resources are here. Additionally, I would request that if you all have resources that you'd like up here, let us know, because we always want to hear feedback from you. So as Megan has posted on your kind of question box there, the website is www.ncmarketready.org. And I'm going to put a little pointer here if I can do it. There we go. And this will be your first screen that you see. And what I've highlighted is, again, that the screen, this will be scrolling, but right here we've got the new name and new look. And you can click there and have more information about that. So in scrolling down from that first part of the screen, you just go down a little bit further, and again, you'll click on this Fresh Produce Safety tab. It'll take you through kind of an intermediate portal, and then you'll get to the Fresh Produce Safety site. As some of you will notice, again, there's a different look. It was formerly called the NC Fresh Produce Safety site. It is now NC Market Ready. Most of the information that's on here will be the same. It might look a little different. So the screens that I'm going to take you through today, the content will be there. It might be found in a different location because this is going to go through kind of a streamlining. So that said, I want to take you through some of the left-hand options on the website. And the first one that I want to show you is using the audit. If you click on that, the screen that you will see that will come up is a list of many audits that are out there. And this is one of the tools that I use as when we go through training with growers as their takeaway, like homework that they can do, is the first one. And it's a self-audit that was created by UC Davis. It is both electronical or it can be printed out and they can do it. But it's a checklist so they can start identifying some risks that are on their farm. Great handy tool. There's also all of the auditors and any kind of like safe water management. If you go down here, there's a self-assessment. Really nice tools, and it's a nice takeaway for the growers. As you're working with growers. And also growers that are on here, it's a great tool as you're starting this. Next, going down the list, if we go into the commodity specific, I highlight this because I'm getting lots of questions in the areas of, okay, I'm doing berries or I'm doing apples. What is there out there for me? And so specifically in the apples, there's a great, again, checklist working with the food safety practices for producers of apples. And so there's some great commodity-specific tools as you work with your growers and as growers kind of go through this process. The next thing I want to show you is the food safety plan. Again, we're just kind of working down the left-hand column of our website. Food safety plans, there's some examples. This is one of the big hurdles that we're finding with growers is that they don't know where to start. Okay, their end market is telling them they need to have a food safety plan and have no idea where to start. This is a very short list. I will tell you that hopefully in the next couple of months we will have something online that has been developed that's a little bit more specific to the USDA audit. It is a working template that was created by myself and Chris Gunter and John Rushing, who's from Food Science. And I think it will be a very effective tool for you as you guys work with some of your growers. If anybody is in need of that currently, just email me and I can send that to you directly before it gets up on the web. The next thing is just a lot of times you don't know where your audience is. And this link, Good Agricultural Practices, gives you from beginning, starting with, okay, this is what good agricultural practices are. It gives you, if you go down on your page index, you've got your historical perspective, gives you the Bioterrorism Act, and it gives you kind of all of the background information that growers need to start with. It also gives you a link to the guide, the original guide for the microbial risk that I mentioned in the beginning that was formed in 1998 by FDA. Okay. The next link is dealing with the Fresh Produce Safety Task Force. I mentioned that there will be 4 of us actually presenting this curriculum. This is a little bit more about what the North Carolina Fresh Produce Safety Task Force is. It's very unique in that we don't know of any other state doing this. There's partnering agencies that are bringing together FDA, NCDA, North Carolina Farm Bureau, NCA&T, NC State, commodity groups, actual growers, and the retail entities all coming together to talk, to figure out how we fund certain things that are needed and whatnot. So it's a nice organization and cooperation between different people, and look for big things coming down the road from them. Okay, so what I wanted to show you, again, I'm still on the main page, and I've scrolled all the way down to the bottom. And I want to show you 2 resources. One is the educators and also the growers. Okay, these are 2 links for the specific audiences. And the first one I'm going to go to is, I believe, the growers resource. Yes. And on the growers resource, this will expand heavily as I get more questions and recognize more needs from growers. But this whole page index is it's broken up into topics. Composting, we get lots of questions. What do you mean by I need to have proper composting? What are those composting guidance documents, or where can I find those? So that's where this whole growers resource list is. Like I said, there will be an expansion of this. We have signs, we have a whole bunch more of information here, and it's designed to, once the grower's actually gone through that checklist and understands they have a need for a certain area, like they need to understand more about traceback. There's a link here on the traceback, and they can find more documents to give them help in defining what they need for their particular operation. Okay, I'm going to switch to the educational resources, the educators' resources. This is designed to gather all of the existing information that's out there. The whole website is designed to be a comprehensive list of resources from all over the United States, Hawaii, just everywhere, trying to pull it all together. And so this is not just targeted to extension agents. It's targeted to anybody that's doing trainings. And so right here you've got a list, you've got a link to the University of Maryland's training manual. They did a Train the Trainer manual. It's a great resource, fills in maybe some of the holes that we have in our curriculum and complements it quite nicely. The other thing I wanted to show you is, and I've got a little arrow here, on the top right you've got Extension Agent Sign-In. This is going to be an agent-only area, and we're going to house all of the resources that have been sent to you, and also trying to give you an opportunity to capture this information so we can do the certificate, like what Chris shared with you. When we have these trainings, the agents will do the Tier 1 trainings, and if they have a group of growers that's completed that Tier 1, we want to be able to capture that information so that A, the grower can get the certificate, but also that they get acknowledged on the website so that end marketers can go to that list and find them based on commodity, maybe based on location. We'll have that printed up onto the website so that there is that incentive, the market incentive for them. So you will go to a main, it'll click onto a main agent resource list. And as you will see on the left-hand column, it is not just fresh produce safety. Fresh produce safety is just one of the areas where there is agent resources. There's all the other resources such as the business management and grower information portal that is other parts of the NC MarketReady team at Kannapolis. So don't be confused. Trying to kind of streamline once again so that you have one place to go. So if we click on the fresh produce safety, you will have the beginning. You'll see some of this is already loaded, the educational curriculum and the webinar series. And on there, it is not loaded yet, but it should be within the next couple of days. We're hopeful. Our programmers are working very hard at it. But and by the end of this series, which would be November 20th, we will be able to go into this and enter information from it'll be the agent information that has trained the growers, and it will be growers information so that we can automatically generate this certificate of attendance that they can then show their consumer, that end market that they're trying to show that they've gone through some training. They'll have their name printed on it, and it will also have the information about the Tier 1 program, the training, and what actually was captured in the training. So, and it will indicate that there was 7 hours of training that they've attended. It will also generate you some questions for grower information when you're filling this out. It'll ask the grower's name, the name of the business, the commodities, and production acreage, so that we can then put that up on the website and be able to let those end markets, say Food Line is looking for more local food. They can then go on our website and say, okay, I want tomatoes, and find the list of growers that have gone through this Tier 1 or Tier 2 as it would be as we kind of roll this out, and be able to contact that grower directly. Okay, so I've finished taking you through a brief overview of the website, and I'm going to pass the baton again to my colleague, Dr. Trevor Fitzer. Dr. Fitzer is a microbiologist in the Department of Food, Bioprocessing, and Nutrition Sciences, and he will be starting to take us through Module 1. So for those of you that are just here for the beginning portion of this to understand the tiered educational program and where to find out how to do the certificates and everything, that portion of the program has concluded, and we will start the module presentation.
All right. Sorry, I was trying to figure out how to turn on my microphone. I'm going to talk to you again in the beginning here about kind of an introduction to why produce safety is important, some of the microbes of concern. Again, for those of you that are extension agents, you'd probably use portions of this at the beginning of your talks to really at least help people understand why they should be concerned about food safety. In this module, we're going to develop an understanding of foodborne illness and the different agents, the bacteria, the viruses, and the parasites that are associated specifically with produce, although you can find them in other foods as well. Again, we're going to understand the differences between them. We'll briefly touch on chemical and physical contaminants, although these are much less of a problem than the biological contaminants. And we're going to talk a little bit about good agricultural practices versus good handling practices versus good manufacturing practices, and HACCP, and a little bit about what the differences in those systems are, because that's a question that we commonly get. All right, so this is a list of the topics that we're going to cover in the module, and again, I've kind of been through all this already in the previous slide. Why does it matter? And again, I guess a large part of this module will initially kind of, it can be a little frightening for some people because we talk a lot about the epidemiology of what's been going on. And for those of you that are going to have to present this before, it's different each time I present it a little bit, but the module companion that goes with it has kind of a scripted parts of what I think are really important points for each slide, so that you'll be able to talk through it fairly well. All right, so why is fresh produce becoming a riskier food? Well, you can see here on the slide, each person is consuming, we're consuming a lot more produce than we were a couple decades ago. Excuse me. 20 pounds more per person, and that's really good from a public health standpoint, but it's also causing us to see a few more outbreaks than we did before. We're also seeing a change in the way produce is distributed and consumed, and I'll talk a little bit more about this in a little bit, but it's not just seasonal anymore. It's coming from all over the world, and we can get any type of products we want in the grocery store now. We don't have to wait till it's strawberry season. We can get strawberries all year long. The other thing that I'll illustrate later on is that, and you guys I'm sure are well aware of this, the distribution system for produce is a lot bigger. I mean, produce comes from a lot farther away. It travels farther across the country and is distributed much more broadly than it used to be. I mean, it used to be more of a local thing. And again, local versus things that have been shipped internationally, each one is just as likely to be the cause of an outbreak. But the outbreaks for the nationally distributed produce, as we'll see, are much larger, whereas the outbreaks for the local foods are going to be local. So they both are, just as likely to cause outbreaks, but we're seeing larger outbreaks because things are shipped farther these days. Okay, so what are some of the challenges that we have with produce, and why should we be concerned? Well, with food safety as a whole, we see contamination and events for microbial contamination anywhere from the seed. There was a big outbreak just recently with sprouts where the seeds that the growers got were actually contaminated with salmonella, all the way to problems with the consumer. Now we tend to think I know we're dealing mostly with the growers and different parts of the chain. The consumer does have a role to play here, but again, the outbreaks that the consumer's doing when they're preparing it in their home are and cross-contaminating things there are generally going to be their family, and it's not going to lead to a large national outbreak for the most part. The other thing, one of the challenges that we're addressing with these modules is the education of both the growers, and eventually we're going to design a similar tiered approach for all the different parts along the supply chain as well, the distributors, the retailers, and the consumers as well, so that they can get the same type of training targeted to them. But the biggest challenge with regard to fresh produce is this one right here. There is no kill step. If I'm making some other food product, if I'm making even canned tomatoes, those tomatoes are heated, and that heating will kill the pathogens that are potentially there, so it'll make it safe. But with fresh produce, there is no actual step in the chain that can kill the pathogen, so it makes it a more difficult problem to control. We can't concentrate on that one element where it's heating the food. We need to try and keep the pathogens out, and you'll see as we go through these things over the next few days that really a lot of good agricultural practices is environmental, and we're trying to prevent the pathogens from getting into the food to begin with, because we can't kill it unless we're cooking it somehow. There's no kill step for fresh produce. And then the other thing that's a big challenge are the outbreaks. Again, each outbreak has a big effect on the on the industry, and we'll talk a little bit about the recent outbreaks and the effects that they've had on the different industries, the spinach and tomato industries specifically. Now, to go on, I can talk too long on each slide probably, but to go on a little bit, talking about why we should care, this is some information that you'll see in just about every food safety grant that's ever been written in the beginning of most food safety chapters. So every year, 76 million people are getting sick, 325,000 people are hospitalized, and over 5,000 people die from food-borne illnesses each year. And you can see here the economic losses related to these are pretty big. This study that everybody has been referencing for quite a while is over 10 years old, and the numbers are probably into the hundreds of millions. So it is a big, or hundreds of billions, and it is a big problem. It's big economically, and there are a lot of people affected by it personally. I mean, when people are dying, it'll have a big effect on a community, on a family, and of course on the individual themselves. Some more recent information that we have is that a number of researchers have suggested that it used to be when I was taking food microbiology, they said, oh, you don't even worry about produce. It's not a problem. And this was back in the mid-90s. You know, most of our issues are animal related, and they still might be a bit animal related, but we found that produce is a major vehicle for foodborne illness. In fact, it accounts, like you can see here, for about 29% of the foodborne illnesses out there, and that's really the largest percentage associated with any class of food. There are other things that are rivaling it. Eggs and meat still are an issue in many cases. All right, so foodborne illness associated with produce, as I said, well, I didn't say this, it is increasing over each of the past decades, from the 70s, 80s, 90s, and today. Sound like a record or a radio station there. You can see that we've had an increase during each decade. Now, there are a few different reasons that we're seeing these increases in outbreaks. First, as I said, people are eating more produce, so we're starting to see it a little bit more often. Secondly, and I'll use the the spinach outbreak to illustrate this. In the spinach outbreak, 205 people were sick, 103 people were hospitalized, and 3 people died. It all came down to about 1,000 pounds of spinach produced in California, and you can see that the food was distributed broadly across the United States, so people were sick all over the United States. And that just illustrates the distribution of the food that we're consuming. So it's more broadly distributed. We're seeing larger outbreaks, and that's one of the reasons that we're seeing more outbreaks, again, because this distribution system has changed substantially. For the next slide, I'll move on to the tomato and peppers outbreak that happened in 2008. Again, you can see that there were cases in just about every state. So that the tomatoes and peppers were widely distributed, and they had actual what I want to explain here, another reason that we're seeing these outbreaks and why we're seeing that each of these states is not its own separate outbreak, is that the public health folks are talking to each other a lot more. So what happened here and what happens in most outbreaks, somebody, say in Washington here, gets sick, they go to the doctor and they take a sample and they're able to identify that bacterium, and in this case it's a salmonella, and they can get kind of a pattern of its genome. They can identify the genome of the organism, and they put it into a database called PulseNet, and they can compare it to the cases that happen in North Carolina and say, hey, look, it's the same organism in both cases, so this is actually one big outbreak. It's not isolated to Washington and to North Carolina, and it's not just a few people getting sick in each place. It's a really big outbreak. So this is one of the other reasons that we're seeing huge outbreaks. And by the way, this outbreak was really quite financially, as all of you are aware, quite financially devastating. Florida lost more than $100 million because of this outbreak, and Georgia lost about $14 million. and people are still trying to recover from this financially from this outbreak. Excuse me. All right, so now back on to the story, and so so there are two reasons that we've gone over so far as to why we're seeing more outbreaks. Three. Populations eating more fresh produce. It's distributed in a larger fashion, so we're seeing bigger outbreaks. And then the surveillance mechanisms that the public health system uses are much more advanced than they were back even in the early 90s, so that we're able to identify that things fit together in our one larger outbreak. Now, the last reason that we're seeing an increase in foodborne illness outbreaks is that we're seeing a lot of bacteria and pathogens in places that we didn't think we'd see them. Again, back when I was taking food microbiology in the early 90s, they didn't think that we'd see E. coli associated with spinach, or apple juice. But we are seeing it there. And I was actually just at a talk down in Savannah where they were talking about microbial pathogens as a whole from a medical perspective, and how, they showed that once we developed antibiotics, we started defeating these pathogens. But what they saw was other things always come up to fill these niches, that we kind of defeat one thing and something else becomes a problem. And I think we'll continue to see that in the industry as we go along. They're called emerging pathogens. And even when we think we have a handle on salmonella and E. coli and the different viruses we'll talk about, something else will then become a problem as well. So unfortunately, I don't think we'll ever quite escape the issues. All right, so as I was talking about a little bit in that last slide, the outbreaks do have, aside from the huge personal burden of people getting sick, they do have a pretty big financial burden as well. And the spinach outbreak, for instance, that occurred in 2006, the spinach growers still haven't completely recovered, and sales of bagged spinach are still below what they were at the time. And you can see here that you can see this statement from one of the CEOs of a fruit and vegetable company, that they were incorrect in assuming that consumers would return to bagged spinach. Because of that, they had to cut acreage, sell lands, and raise their prices to account for the loss in sales. In fact, the farm that was responsible for the outbreak did end up going out of business, so they really had a huge financial impact. So these outbreaks, again, are really difficult for the industry to overcome. Another thing that we do hear a lot is that it's something that just happens out in California. These outbreaks are due to the leafy greens in California, or maybe the tomatoes up in Virginia, but it's not something that's local. Well, I'd heard this enough and from a number of people, so I decided that I needed to go in and actually find out, is it a local problem? Well, it is. When I looked back through the CDC literature from 2003 to 2005, and they list every outbreak that has occurred, I found 19 produce-related outbreaks occurring in the southeast. And again, you can see more than 1,400 people became sick. The largest outbreak was 425 people, and as with most leafy greens outbreaks, the primary agent, causative agent, was Norovirus. Now, these outbreaks are, people do get sick, and it's not just due to, as I said earlier, it's not just due to the food from California. It can be due to local produce as well. When I first started here, there was an issue with a grower in the western part of the state where they were responsible for a hepatitis A outbreak in their region, and they were a small local farm, but they still had think it was 30 or 40 people sick in the area, and again, the end result was that the field had to be plowed under, and they traced it back to a water quality issue with the water that they were using to water their crop. So that just, again, it's important. That's one of the big arguments that we keep hearing, is that it's not going to be a problem if it is local produce, but it can be. It's just as likely to be a problem if it's local as it is nationally. It's just that the outbreak itself will be more localized, not any smaller, not necessarily any less devastating. In this slide, I wanted to show a little bit of some of the other effects on business. We talked a little bit about the effects that they had in the tomato outbreak and the spinach outbreak. Well, some of the older ones that people have studied, the strawberry industry back in the mid-90s lost $50 million when they were just implicated as being a source of pathogens. It turned out it was actually raspberries and not strawberries, and the raspberries had come from Guatemala, I believe. But it still had a huge effect on the strawberry industry, just to have people think that they were associated with that. And this was back when the news cycles were a lot longer, and it took, a few days to a week for information to come out. Now, if you talk to Ben Chapman, he said the news cycles are, hours instead of weeks, and they can even have a more immediate impact on different commodities. One of the more famous outbreaks that occurred was this one right here, the Odwalla outbreak. Again, Odwalla was a juice producer that that made its name making pasteurized juice. And they are making non-pasteurized, fresh juice. It was fresher, it was better for you. And they washed their produce with acids, or washed their apples and the different fruits that they were going to juice with acid, but they didn't have a pasteurization step. And their business grew really rapidly. They became a pretty big company, selling mostly along the West Coast, and they were just starting to expand into the East Coast when about 60 people got sick from drinking some of their juices back in '96, I think it was, and one little girl died. One of the things about foodborne illness is that it really affects the young and the elderly primarily. So generally, if people are going to get sick and die, it will be someone's child or someone's grandmother or grandfather. And generally, healthy, normal adults will get sick, but they won't die. So in this Odwalla outbreak, a girl died, and they've really become Odwalla has really become a beacon as to how to survive and how to overcome an outbreak. They really took responsibility for the outbreak. They immediately said that they were going to pay for the medical bills of the people that got sick. They did end up getting sued by a large number of them and paying out over $12 million in lawsuits. They also got fined for $1.5 million by the FDA, and that's the largest fine for criminal negligence in food safety that has been done. But Odwalla owned the outbreak. They said, we did it. They did as much as they could to help the people that were affected. They didn't lay anybody off. Any of the people that they had working for them that they thought they might need to lay off, they put them out in the field and helped them, have them contact customers to try and regain that trust. But more importantly, one of the things that they were able to share with everybody is that they said, hey, we made a mistake, and they started pasteurizing their juices. They cleaned up their plant and their equipment, and they had some of the best food safety programs in the industry put into their plants, and really, they were really able to rebound from it. And somewhere around 2002, Odwalla was sold to Coca-Cola for $181 million. So they were able to actually survive that outbreak and and rebound nicely by effectively managing the crisis. As you can see here, some other effects of outbreaks are reducing the effectiveness of the promotion campaigns. It just gives people another reason to not want to eat fresh produce. You know, people aren't coming back to the bagged spinach is a good example of that. And then this last one, it kind of depends on who you are. Some people will say that the legislation that is probably going to be coming, you know, it's already moving through the Congress. Some people do want it and some people don't. It depends on who you're talking to, but each outbreak really tends to lead more and more towards this legislation, whether you want it or not. Now, again, with each outbreak too, you see a response by the retailers selling the food. They want to make sure that you know, they're selling vegetables and produce that are safe and that people aren't going to get sick. Because remember, when somebody gets sick, it's everybody that's touched that piece of produce will probably get sued, not just the grower, but the distributor, the retailers. Everybody will get sick, and that's why the grocers tend to have this response here, where they want to make sure that they're selling safe food, and they want their suppliers to have implemented gaps. And right now, since we don't have any legislation yet, people being GAP certified really is a buyer-driven type thing. They're really the ones that are driving the certification. And that's an important thing to remember right now. The good agricultural practices are still voluntary, and it really, for each grower, it depends on who their end market is, on whether or not they'll be required to be certified. So that's a little bit about why we should care about produce safety, both from the economic and personal side of things. Now I'd like to switch gears a little bit and talk about the different pathogens that we worry about in produce. Again, there are three basic types: bacteria, viruses, and parasites. The bacteria are the ones that we hear about most commonly, you know, the E. coli, salmonella, listeria to some extent. But the viruses are the ones that are most common to, they actually produce the most foodborne illness. It's just that most of those outbreaks are a little bit more localized, and people generally aren't going to be dying from the viruses, where people from the bacterial outbreaks will be getting sick and dying lots of times. And then occasionally we'll have parasite-based outbreaks, and I'll talk a little bit about the differences in each of these types of organisms as we're going along here. Now, with bacteria, there's a long list of bacteria here. There's actually Norovirus here is actually a virus and not a bacteria, and we keep forgetting to remove that from this slide set, but it shouldn't be on this list. The guys that we tend to hear the most about in terms of pathogenic bacteria, especially associated with produce, and there's a slide coming up that'll say this as well: Salmonella and E. coli. These other guys we have seen at different times in produce-related outbreaks and in a number of different food-related outbreaks. Listeria here is one of the ones that we worry about a lot, because it tends to have the highest fatality rate of any of these foodborne pathogens. It also affects pregnant women. They tend to it causes spontaneous abortions and meningitis in normal people, and a lot of the times when people get listeria, it'll be a flu-like symptoms for a while. But we've seen it in produce a bit, but not as much as Salmonella and E. coli. These are the big two, actually, as far as bacterial pathogens are concerned. And you can see here, this is the list of the guys that have been in fresh produce-related outbreaks. E. coli 0157, as I said, and Salmonella are the two that you hear about the most. We'll talk a little bit about where these guys come from, how they get into the produce in a little bit. Hepatitis A here is a virus, and it's another one that should have been on this list but was on the previous list is Norovirus. Again, so those are the two viruses that we primarily worry about. Then the Cyclospora and Cryptosporidium here are actually parasites, so they're not the same as the bacteria or the viruses. They reproduce differently, and they're actually more similar to our own cells, so it's difficult for us to get rid of them. But again, I'll talk more specifically about them in a minute. With bacteria, and specifically with the spinach outbreak, one of the things that was really sad about the 2006 spinach outbreak, and even to some extent about the people that were teaching me food microbiology, before that spinach outbreak in 2006, when everybody really jumped up and became aware of the problem, there were 30 other outbreaks of E. coli 0157H7 associated with leafy greens. So again, along the way, somebody should have seen this coming and should have said, hey, there really might be a problem here, and it's something we should start looking at, even much earlier than we did. You will, to make a note of it, the guide for fresh produce safety that the USDA released did come out in '98, so they at least did have some idea that this was going on and tried to take some steps, but as with many things, it doesn't become a big issue until it grabs the public eye for a little bit, and then they become concerned about it. You can see this is just continuing that list of outbreaks with E. coli. Now, those are the pathogens that we generally worry about, whether they're viruses, parasites, or bacteria. These are the commodity items, or the produce items that the foodborne illness outbreaks have most often been associated with: leafy greens, tomatoes, sprouts, berries, and melons. So these are kind of the big five, and that's part of what goes into an investigation, is that when, say, in the tomato outbreak last year, the tomato pepper outbreak, when their CDC is investigating, they're using what they've seen in the past to try and figure out what the most likely carrier of the pathogen is. And so when they're looking, they'll see that leafy greens were eaten or that tomatoes were eaten, and they've seen salmonella associated with tomatoes before. So that tends to be more of a focus for them than, say, the peppers, which they'd never seen, well, they hadn't never seen, but they hadn't seen associated with salmonella as often as they had tomatoes. So they're trying to narrow the odds as they go through. And one of the things that they do tend to look at, you have specific pathogens that tend to be associated with certain types of produce items. They're 0157H7 here tends to be associated with leafy greens. You'll see it with sprouts, and then unpasteurized juices. Again, that was what was responsible for the E. coli outbreak with the Odwalla apple juice. And coincidentally, I forgot to mention earlier that after that Odwalla apple juice outbreak, the FDA did come down and say that all juices must be pasteurized. They have to somehow show a 5-log reduction, so that they weren't allowed to sell unpasteurized juice. You still can if you're small, but you need to have warning labels on it. But most of the producers are now have to sell pasteurized juice legally, and they actually have to have a HACCP plan in place. So the types of things that are happening to the produce industry right now have happened back in the mid-90s to the juice industry, and happened around 2000 to the actual seafood industry as well. All right, so back on to the story here. So you tend to see E. coli associated with leafy greens. Salmonella is associated with a lot of different things. It's pretty prevalent throughout the environment. The big ones are tomatoes and actually cantaloupes, melons we've seen quite a few of, but you can see that it's found in a lot of different things. Alfalfa sprouts, root vegetables, peppers. It's also been seen in Europe on a number of leafy greens as well. The Listeria here, we haven't seen as many outbreaks with Listeria. You typically see E. coli and Salmonella causing the large outbreaks, but Listeria has been found on cabbage and lettuce and other leafy greens in the past. I just saw a paper recently where it was also found on melons, cantaloupes, and was responsible for an outbreak there. And then this last guy here is Bacillus cereus. It's been found on sprouts, but it's often associated with rice, whereas Listeria is often associated with deli meats and deli salads. But it has been found on produce as well. Okay, so one of the things about bacteria compared to the viruses and the parasites, bacteria will grow and reproduce on their own. And they grow logarithmically. So if you have one cell, it becomes 2 cells. The 2 cells then become 4 cells, and the 4 become 8, 16, and so on. And because of that, they can grow very rapidly and increase, very quickly. The bacteria that has the fastest growth rate can double every 10 minutes. So you can imagine, this is if it's in its optimum environment. If the pH is right, the temperature is right, the humidity is right, it can double every 10 minutes. And so you can get a substantial population in a very short time. In the example listed here, you can see that population going from one bacteria, gets very large very quickly, into the billions very quickly. Now, one of the things that I do as a food scientist is to try and figure out how to slow those bacteria, how to slow their growth down. That's part of the reason we refrigerate things, because that slows bacteria down. They don't grow as quickly at cold environments. If you're acidifying things, it stops the growth of a lot of different bacteria. So that's what we're trying to do. This fact that they reproduce has implications throughout the distribution line. That's why maintaining cold chain is very important. Again, it's helping to prevent the growth of these bacteria, because they'll grow as long as there are nutrients there. It also makes them, for me as a microbiologist, easier to detect, because I can grow them. I can grow them on and plate them on different media and figure out what they are fairly easily compared to the viruses, for instance. Now the viruses, that was a pretty nice lead in there. The viruses that we're concerned about, there are really 2. There's hepatitis A, which is listed first here, but the one that we see the most cases on is this Norwalk or Norovirus. Sorry. These guys are a bit different than the bacteria in that they actually can't grow on their own. So the bacteria are able to grow on their own, but these guys can't grow on their own. They need a human cell to be able to grow. They have to have been in somebody's intestinal tract because they need those cells to grow. In fact, hepatitis A we can grow in the laboratory by taking human cells and growing them in a petri dish and infecting them with the virus. Norwalk virus, we haven't even been able to figure out how to grow Norovirus in the lab. We've tried a bunch of different, human intestinal cell lines, but we can't get it to grow. So since these guys need to have human cells to be able to grow, that means that they can enter the food chain in only one way. Somehow, somewhere, whether it's into the irrigation water, into the field itself, from the handler's hands, in the kitchen, human feces have to have gotten into the field somewhere, because that's the only place they could come from. So somewhere somebody, took a dump and that got into the field. There are a lot of different ways that can happen, but it had to happen to get one of these human viruses there. That's led to, well, my wife's lab actually works on Norovirus. She works for Leanne Jacobs, and one of the things that they did when we first got here was take fake feces and look at the transfer rate of the virus from the fake feces to the hand, and that was one of the first things she did, and that was not too much fun for her. We almost left shortly after that, but it was a good experiment. All right, now the viruses have been associated with a number of different produce outbreaks. We've seen hepatitis A associated with lettuce, raspberries, strawberries, and green onions. In fact, one of the largest outbreaks with green onions occurred in Pennsylvania, where over 640 people got sick from eating spring onions that had been infected with hepatitis A. And they traced that back actually to contaminated irrigation water. Norovirus has been associated actually with lettuce, but with just about anything. It's very common as a cross-contaminating organism. Again, people not washing their hands well enough. And the viruses aren't going to be growing on the food. They're just going to be sitting there, not growing. But the fact that they're sitting there makes them harder for us to detect because we can't grow them on different media. The other place you might have heard of Norovirus here is as the cruise ship virus. It's the virus that people go on cruises and tend to get sick when they're on the cruise. Again, it's caused from some of the same things. It's from people not washing their hands. It can be caused from people vomiting, and the aerosol spreads the virus. In fact, Leanne's lab is actually going to be studying that. And really, it's a good reason to think about sick workers, and if they are sick, maybe you should have them assigned to doing something else for that day, or not even coming in, because again, it's very easy to spread these viruses. They're going to be having diarrhea, they're going to be vomiting, and just aerosols from these can spread these viruses fairly well, and they can last for quite a long time, 6 weeks or so on a surface that people will then pick up and get sick. All right, now the parasites are a little bit, I guess you could think of them as kind of falling in between the bacteria that can grow in lots of places and don't necessarily have to come from humans, and the viruses that do have to come from humans. The parasites that we primarily see with produce are these three right here, the Cryptosporidium, Cyclospora, and Giardia. They have a life cycle where they grow in the intestinal tract of whatever their host is, and then they produce spores, or what's called a cyst, and that cyst gets passed through the feces of whatever is carrying it to the environment. You often find them they're big issues in water. And those cysts can survive all sorts of stuff. They're not as hardy as bacterial spores, but they can survive chlorination, and pretty much the only way to get rid of them is filtration. And then once those cysts get consumed by, say a human being, even if they came from an animal, a bird or what have you, they get consumed by a human being, and they germinate into these parasites that will then live in somebody's intestine. And generally these guys cause really bad diarrhea for a fairly long amount of time, a few weeks, and they're very difficult to treat because they're very similar to our own cells. They're what's called a eukaryotic cell. So they're very similar to ours, and so it's hard for us to get rid of them. One of the largest outbreaks that I remember is with Giardia here, and it actually infected the city of Milwaukee's drinking water that they were getting from Lake Michigan, and I lived in Chicago at the time. And over 1,000 people became ill just from Giardia and had diarrhea for quite a long time. It was one of the first big outbreaks I remember, and I was it started to get me really worried, and actually I guess kind of interested in this food and water microbiology and how to protect people from those outbreaks, because you want to expect that your water supply is safe to drink and your food supply is safe to eat. All right, so we have seen again these guys associated with produce outbreaks. We have the Cryptosporidium, a famous case with apple cider. Again, people were using dropped apples, and the apples were sitting in cow feces, and the feces had the spores on them that were then made into the apple cider and consumed. We've seen cyclospora in connection with raspberries, but again, we've seen them with other things as well. But typically, we do see them primarily associated with berries, although I've seen some papers linking them to some leafy greens as well. And again, it makes sense because they're generally coming from infected water. They're a big problem in the water supply. So I guess that leads me to, where do these guys come from? Well, there are a few different places. Again, if we were actually live, I'd be asking you guys to tell me where you think they might be coming from. But since it's harder to ask questions here, or this is the first time I've done this, I'll just step right out and tell you. These guys come from a few different places. The first is the soil. The Listeria, Bacillus cereus, and Clostridium botulinum, the cause of botulism, which is an outbreak of botulism is considered one person, and people almost always die from botulism. It's typically from canned foods, but you can find these organisms in the soil. If I went outside my office right now and got a gram of soil and did the microbial analysis on it, I would probably find at least 2 out of the 3 of these all the time in that soil. Could be any of them, could be all of them, just by looking at that gram of soil. Now, you can find some of these other pathogens in the soil as well. E. coli 015787 and Salmonella will persist for months in the soil. But that's not where we typically find them, or where they live and grow normally. We find them in the intestinal tract for Salmonella, birds and other animals. Typically we'll see the Salmonella there. Again, if humans are infected, they might be passing it for a while. E. coli, we typically see it in ruminants. It's 015787 is in the cattle's intestine pretty often. We also find it in deer, boar, pigs. Again, it can be found in some asymptomatic humans as well. And they live and grow there. Now, if I looked at everybody's intestinal tract that's on the line here, you actually have more bacteria in your intestinal tract than you do cells in your body. And E. coli, not necessarily 015787, but E. coli is a part of that microflora that's in your intestinal tract, and they are actually beneficial. They help make vitamin A and help break down various foods in your intestinal tract. So we do want them there. Hopefully it's not 015787. And that, I guess that also leads to, when we're looking at water quality or produce quality, one of the things we'll look at are the generic E. coli numbers, or the fecal coliform numbers, which E. coli is a member of the fecal coliform group, just to show that if there's been contamination by feces, because that's where they come from. These guys are going to come from human or animal feces. The Campylobacter we'll typically find in poultry. It actually grows prefers to grow at a higher temperature. Salmonella, E. coli, Shigella will grow at 37 degrees Celsius, which is pretty much body temperature, 98.6. Campylobacter here prefers to grow at 45 degrees Celsius, which is the body temperature for chickens. So it's typically found in birds, not as much in humans. But again, those bird feces getting into the field can lead to Campylobacter being there. Now the last two here, Shigella and Shigella here and the viruses, these two have to come from, they only grow in human, the human intestinal tract. Shigella is a bacterium, and it can grow a little bit out in the environment, but it's not going to last for very long. We don't typically see it in animals. It's typically seen in humans, and it causes dysentery, so a lot of diarrhea. And the viruses as well, as I said earlier, they need to have humans present to be able to replicate. So somehow if those guys are in the field, human feces had to get in the field. For the Salmonella, E. coli, and Campylobacter, there could be human contamination, but it can easily come from a number of different animal sources as well. All right, so oh, and one thing I'll mention before we go on to how often we find these guys, just a quick word that typically for these guys, in most cases what you'll see as symptoms are nausea, vomiting, some diarrhea, fever. In the case of E. coli, you'll see some O15787 is so dangerous compared to some of the other E. coli that make you sick because it can also affect the kidneys in something called hemolytic uremic syndrome. And actually that's what tends to kill the children. It shuts down the kidneys and they end up getting really sick from that and having long-term problems. The viruses are typically, well, Norovirus is going to cause vomiting and diarrhea, and hepatitis A is going to cause kind of flu-like symptoms and jaundice, really. It'll affect the liver. It's not a chronic disease like the other types of hepatitis. Hepatitis A is self-limiting, so people will get it and then get over it in a few weeks. Just to touch on what those guys do. Now, one of the things that a lot of people suggest is that we sample the fields quite often to find the produce or to find the pathogens in the field. Well, if you remember with the spinach outbreak, the whole outbreak came down to basically one turd in a ton of, or in 1,000 pounds of spinach. So that's a very small percent that was actually contaminated. And when people have gone out and tried to find these pathogens in the field, it's very difficult to find them. You can see on the slide here that Salmonella is only present from about 1 to 8% when they're out screening for it. And Listeria is a little bit easier to find because it's in the dirt, but it's still not present all that much. And again, we don't see nearly as many outbreaks from Listeria associated with produce as we do Salmonella. So it's very difficult to go out and walk into a field and figure out if there's going to be issues from sampling for Salmonella or not. You know, the rest of the food industry has that problem as well. It's really hard to sample and say that a negative sample means that that's safe, or that a positive sample means that the whole thing is contaminated. Sampling, well, if a positive sample is there, it's going to have to be recalled. But a negative sample doesn't mean that it's not there because it's there in such a small amount. If you think about sampling a field, you know, if I'm sampling tomatoes and I grab one tomato, even one tomato off each plant, it might not be that each tomato is infected. They might not have bird poop on it, or they might not have gotten, you know, sprayed with water in just the right place for the pathogens to survive. So I might pick the wrong tomato in each case and not even see it while it's present in that field. It's really well illustrated by the peanut butter problem that people have been having recently. If you think of a jar of peanut butter, all right, the company, the PCA down in Georgia, they had that jar of peanut butter. They sampled it. They got a salmonella positive. They went back to that jar of peanut butter. They sampled it again. They got negative. So, you know, they said that that sample was clean when it wasn't, but it's because the samples aren't, the bacteria, like the field, they're not present, you know, in a homogeneous mixture throughout that peanut butter. They're not present throughout the whole thing. They're present in little tiny pockets, and if you're lucky enough to hit one of those pockets, you'll get a positive sample. But just because you don't get a positive sample doesn't mean that the salmonella is not in the peanut butter, and it's the same thing in the field. So sampling is a very difficult way to deal with this issue, and actually in other you know, food production instances, it's what led them to HACCP. They realized that they couldn't sample enough to guarantee that food was safe, and the HACCP system was designed for the space program. They wanted to make sure that what they were sending up with the astronauts wasn't going to get them sick, and they you know, realized that they could not sample enough of the food to guarantee that those astronauts would not get foodborne illness in space, which I can just imagine wouldn't be fun at all. So they decided to look at the processing steps and find a specific point, say the heating, the cooking of that product, and monitor that, because they know what level can kill the pathogen there. You know, what temperature and what time will kill the pathogen, and they did that to make sure that the astronauts weren't getting sick. Well, GAPS that we're going to talk about in a little bit is kind of similar. We can't sample our way out of the problem, so we're trying to make sure that the bacteria, primarily from fecal sources, so the poop's not getting into the field, is what we're really trying to do in most cases. Now, again, with the produce, there is no kill step like I talked about with the HACCP plan, where you can cook something and get rid of it. The pathogens, when they get on the plant, they attach very nicely to the plant, and you can see we have a number of different, doesn't show up too long here, but a number of these little green spots here are actually bacteria that are attaching to a lettuce leaf. They tend to like to attach around the stomata here, which is what this area is. And what they found is that even when they wash these items, and my next slide, if you guys are talking about this, will illustrate that a little bit more, but even when they wash this with all sorts of different washes, and there are thousands of papers out there on doing different washes with produce, that a large number of these bacteria, especially those around the stomata, and they can get inside the stomata, are quite protected from this, and you can't really kill off enough of them to make sure that the produce is safe. And see, that's what this slide is showing. And again, there have been thousands of washes that you know, give you anywhere from a 1 to 3 log reduction, and reducing a log means, you know, if we have 10,000 bacteria, we then have 9,000 bacteria. That's a 1 log reduction. Or going from, you know, 9,000 down to 900 would be a log reduction. And each log reduction, coincidentally, is a 99% destruction of the pathogen. So even when you're seeing like a 99.99% reduction of the pathogen, if you have 1 million pathogens there, you're not reducing very many of them. You know, you're moving it down 3 logs, so you're going from 1 million down to 1,000, and that's still more than enough to make people sick. What the FDA typically wants to see in washes or pasteurization solutions is a 10 to the 5th reduction, which should be enough to make sure that there aren't any viable pathogens really to affect the consumer. Now, I've said that there aren't any good treatments out there right now. There are a couple that I've seen that are promising, and hopefully as time goes on I'll be able to change this story a little bit. And if one of those actually does work well, it will go a long way to solving a lot of the issues that the produce industry has. You can see here a number of different things that people have tried, all sorts of different concentrations, different rinses and washes. As I said, there's some acid mixes that seem to be working pretty well. One thing that I'm sure all of you guys have seen a lot is chlorine. And you know, those of you that have dump tanks and things like that, you're adding chlorine in there. That's really to prevent transfer of the pathogens from one piece of produce to another piece of produce. It doesn't really kill the pathogens that are attached to the produce. They're pretty well protected. And you know, this is not the only industry that sees this problem. In the medical industry, they have all sorts of issues with pathogens attaching to catheters, and when they're attached like that, they get in this structure that it protects them very well. Or even to small plastic pieces that they implant in folks, and once they're attached in what's called a biofilm, they're much more resistant to antibiotics. In fact, some can't even be killed once they're in that biofilm by the antibiotics. All right, so because we don't have a way to kill these guys yet, we've had to look at managing them throughout the supply chain, all the way from pre-planting, you know, through transportation, and really even down to the consumer. We want everybody to understand that they have a role in this. And that's really for the growers. That's what good agricultural practices is the beginning of, you know, really managing, preventing the contamination from entering the supply chain. Even if we do come up with a wash that actually eliminates the pathogens, we'll still need to have these GAPS measures in place to limit the amount of pathogen that gets in there so that the wash can be more effective. You know, if you get, you know, millions and millions and millions of salmonella cells on something, you know, if you have a billion salmonella cells there and you wash it and only remove 5 lugs, you're still going to have a problem. So we still need to try and limit the how often or how much the pathogen gets into the chain. And the first attempt at this, and really what everything is still based on, is the Guide to Minimizing Food Safety Hazards for Fruits and Vegetables, which Diane mentioned earlier. It was published by the FDA back in '98, I believe, and very broad strokes, not very specific in any way, shape, or form. And you know, even in the 10 years since that guide's been published, we're still struggling with being able to be more specific. Fortunately now, lots and lots of research is taking place to help clarify points and to be able to give better guidance than being broad, like keep the animals out of the field or keep the cattle, you know, so far away. We're trying to be able to give better guidance, but it has taken time, and it still will take more time and money to really get it. Now, good agricultural practices themselves are really a tool for keeping pathogens, human pathogens, out of the farm. As I said earlier, right now it's a voluntary program, although lots of it's really being, depending on the grower and their market, on whether they need it or not. And you know, big buyers, Walmart and places like that, are requiring it. Even some of the farmers markets are requiring something be done now. Now there are 8 recommended practices in GAPS, which I'll introduce, but then we'll talk about more specifically in the modules that follow. All right, the first one, prevent microbial contamination, really is what this is all about. Start a program of GAPS, have a food safety plan in place. The one area that we deal with in trying to prevent the microbial contamination are human and animal feces, wild animal feces or pasture animal feces, and trying to keep them out of the field. We also worry a lot about water and water quality, and again, trying to make sure that it's not contaminated. The animal manure down here at number 5 actually refers to if you're using it as a fertilizer, so making sure that it's properly composted. The worker hygiene and sanitation is a important part of it as well. Again, there are lots of regulations regarding workers, and you know, they're pretty much the major source of getting human feces into the field and human fecal contamination into the field. So it ranges from hand washing to porta potties. You also need to follow all applicable laws regarding pesticides and OSHA and anything else that NCDA might be having. And then this last principle here is really one of there's really two things that we talk about here, and to me it's really part of the most important part of GAPS. Record keeping and documenting what you're doing. It's something that nobody wants to do. You know, we all have to keep records of what we do for our bosses here at NC State. So we have to have documentation and records for that. Well, it's probably the least fun that I have is filling out my faculty activity reports and my, you know, extension reports. But it's something I have to do, and it's the same for the growers. You know, if they're doing good agricultural practices, if they're doing the best that they can to keep these pathogens out of their field, if they haven't documented it as far as the FDA is concerned, or if they get into some legal situation, it hasn't been done. They can say they did it all they want, but if they don't have documents showing that they did it, it hasn't been done. You know, so it is something that they do have to think about, and it's probably, in many cases, it might be the biggest change for a lot of the growers. A lot of the things that they're doing, they might have already have done in the past, but this documentation is what would be a new layer added on there to make sure that they're doing what they need to be doing. The other thing is trace back, and I think knowing where your product is going, you know, to the distributor and farther, and so you can trace it back to a field, a time of harvest, and even know who is harvesting it, can go a long way to keeping you out of harm's way if you're growing a commodity that's been responsible for an outbreak, because you can say, look, my stuff never went there. Or it also helps the investigators trace things back and end the investigation a lot quicker if we have good trace back on that commodity. Excuse me. And one of the things that you'll hear is that, you know, well, I sell direct to the consumers, so there's only the consumer and me, but how many people can actually tell you who they sold to? You know, and everybody does need some form of trace back, the ability to be able to tell people that bought their product that they might have a problem. All right, so that brings us to kind of the alphabet soup here. What is the difference between GAPS, good manufacturing practices, good handling practices, and HACCP? You can see there are really two things that are involved in produce, the GAPS and the good handling practices. Good manufacturing practices and HACCP are involved in processing. As far as produce is concerned, they'd be involved in juice. You might have some good handling practice or good manufacturing practices involved in some other fresh cut type operations. While GAPS are voluntary, good manufacturing practices for processors are really not voluntary because they're part of a HACCP program. You have to have good manufacturing practices to be able to effectively have a HACCP program. And these are things like, you know, they look at the types of things people are using on walls, the flooring, their sanitation programs, their pest control programs, and things like that. One of the things, the gaps, good manufacturing practices and good handling practices are similar in that they're all designed really to create a environment for the production of whatever product it is that is not going to have the human pathogens there, and the environment, making sure that the environment will not be a problem. You can see that they all do require record keeping, and none of them have a corrective action really in there. So they're just trying to keep things out of the environment, and there is no corrective action, but in some ways there is. You know, if they found that part of the good manufacturing practices would be not to have water leaking from even a fire safety system into the equipment or into the food processing line. And if they saw that, while it's not part of their HACCP system, it is something that they probably would need to fix. HACCP here is something different. Instead of trying to control the environment and keeping the pathogens out of the environment, as I said, they're looking at specific steps in the production of a product where they can control that pathogen. So a heating step is a very good example. A metal detector to make sure metal's not getting into food. And they monitor that step to make sure that it is at the levels that it will be effective to control the pathogens of concern. They're not trying to keep everything out. They're monitoring a specific step. So they do have corrective action if the pasteurizer is pasteurizing the juice and it's not getting to the temperature and time that it needs to. They might have to run that juice back through to make sure it gets to the time and temperature that it needs to, and that would be their corrective action. So they do have a control point. Right now, HACCP is required if you're, as I said, a juice processor, seafood, if you're doing meat, if you're doing poultry, really if you're doing most food commodities. And for the peanut butter folks, it's soon going to be a requirement in the peanut butter processing, although to be honest, their problems go farther than just implementing HACCP, and it's going to be interesting I'm involved in that too, and it'll be an interesting couple of years for them. All right, I guess if you guys, one of the things that I've heard is people are requiring the growers to have HACCP. Well, that's not really appropriate for growers, and again, it's people getting confused about these this alphabet soup. There really is no critical control point for people that are growing fruits and vegetables. So it's not really something that they can have. They should be having good agricultural practices and good handling practices in the packing shed. HACCP, there's really no step along the way, again, that really kills the pathogen, so it's not really the appropriate thing to ask for. I guess, according to the FDA right now, as we've said many times already, GAPS is voluntary, and part of what we're involved with this session right now is trying to educate and form outreach to the industry so that they're knowledgeable in the guidelines and understand what to do. And again, that's going to become more and more important with the issues coming down, or with the legislation going through the Congress at this time. All right. So what are some of the hazards at pre-harvest? Well, the environment. One of the basic tenets is to know what your land had been used for before. You can get contaminants that come from the land. Were biosolids applied in the past? What was there before you decided to plant vegetables in this field? And might they have an impact on on the produce themselves. You also have all sorts of different agricultural inputs that should be tested and looked at before harvest: water, soil, fertilizers, again, the supplements. One of the things about the fertilizers and the supplements, if they're mixing them, and using the water from the irrigation pond, then they're actually spraying those fertilizers right on the plants. That could be just transferring a lot of pathogens right from the pond to the plant directly, and people would think, well, the pesticides and fertilizers would prevent the growth of the organisms, but they don't. They don't at all. And again, with every step along the way, people and animals are always a problem. We also look at having inappropriate facilities, contaminated tools, making sure that the harvesters are cleaned and sanitized before harvest. Production methods, seed quality. Again, that was an issue with the sprouts earlier this year. Planting distances, fertilization, irrigation, pests. All these things are things that we need to think about before harvest to try and manage the pathogens, preventing the pathogens from getting in there. And in some places there is good guidance, and in others there is still a lot of work to be done to figure out, different spacing and issues like that. The next issue that we deal with is field worker hygiene. You need to have porta potties, and they need to be 1/4 mile away. You want to make sure that they have the hand washing facilities available as well, and they really need to be outside the porta potty so that people can document that the workers are washing their hands and drying them before they go back to work. Water contamination is always a big issue, especially here. We tend to use a lot of surface water, and again, the cattle in the surface water looks really nice. It helps cattle keep cool, but each time they're pooping, unless they're really well-trained cattle, I think Billy used that line first, they're going to be pooping in there. And then that'll be spread, through the irrigation system to the plants as well. So, and again, each of these areas will go into in much more depth in specific modules. There are also hazards at the post-harvest stage. Again, inadequate facilities, not having good pest control, not using good packaging. People have used contaminated boxes and things that really shouldn't have been reused. Inadequate contaminated equipment. Again, you can see the people and animals in here. The different inputs that you'll have post-harvest, so wash water, waxes, things like that. And again, even wash water, is it chlorinated or not? Is it potable or non-potable? These are all questions. Now, we've talked a lot about the bacteria and managing these guys in the environment, but there are other things that can cause foodborne illness outbreaks, although you tend not to see them getting as large as the bacterial outbreaks, because again, the bacterial outbreaks, the bacteria can continue to grow throughout the chain. But there are different toxins, chemicals, and other chemical hazards that you can have problems with. People not using food-grade packaging materials. I deal with the wine industry, and I've had a few people do fermentations in non-food grade, actually plastic tubs that then can cause some problems. Some of the naturally occurring toxins you'll see are different allergens and mycotoxins. Again, the mycotoxins are a big problem in the cereal and nut industry. And the allergens, there are a few people that have allergies to some different produce items, but the big ones are milk, peanuts, seafood, grains, eggs. So it's not as big an issue. You might occasionally see some contaminations with pesticides, fertilizers, or antibiotics, especially going back to what what people had been using the field for before for the antibiotics. If it had been a dairy cattle field beforehand, you might see some antibiotics there. The pesticides and fertilizers, we occasionally see the residues on different produce items. There was a famous incident back in Chile with grapes a while ago. You can get chemical contaminants from different places. People using incorrect sanitizers is an important one. Paints on some of the equipment or the buildings that might not be appropriate. You can get food-grade lubricants for things in the packing house. But again, we tend not to see as many outbreaks related to these chemical hazards as we do the microbial ones. You can find toxic elements, again, depending on what the soil had been used for in the past. You can see a number of these different things, and that's why it's important to know what your field had been used for previously. Packaging materials, again, as I said earlier, different plasticizers and things, and make sure that the packaging materials are food grade approved, and it's simply asking the supplier if they are. You can find physical hazards and things. Again, there was a really nice picture that Ben Chapman had of a frog in a bag of lettuce, which would be the ultimate physical hazard. That could actually provide a lot of microbial hazards too, because reptiles tend to carry a lot of pathogens, including salmonella. That's why you can't transport small turtles that people like to keep as pets across state lines, because they have salmonella in them. You can see a list of the different physical hazards that you might find. Again, usually this is taken care of in the packing house, and just in the case of most produce, a visual inspection. We had some grapes that came into the pilot plant here that had a few snakes in them. That made for a fun afternoon. Luckily they weren't poisonous, but it was a lot of fun. Finally, for people that are interested in going all the way through being GAPS certified, there are a number of different, it'll really depend on who the buyer is as to who they're certified with. We have a lot of information here for the certification done through the North Carolina Department of Ag, but different buyers will require different certifications, although it seems that some of that is narrowing, and people are starting to understand that they can use the same certification for different things. But here's some of the information that you can give the growers on where to contact the NCDA for third-party audits, and even for their program to help subsidize the audits for growers. Oh, excuse me. And this final slide here is a list of the references that we used in making up this slide set. And again, if you guys have any questions about it, feel free to contact me. You can send them on in the email here, or you can just email me. Just search Trevor Pfister, and I'm the only one out there on the internet, and pretty easy to find. I'm in the Department of Food Science, Food Bioprocessing and Nutrition Sciences here at NC State, and again, you can find me there if you have any questions about this stuff, or just call, Chris. He'll give out his cell phone number, and he likes to be called generally somewhere around, 2 or 3 in the evening, in the morning, so that would work too. Thanks for listening today, and I hope you guys enjoyed the session. This is the first one I ever did. It's a little bit weird to talk to no audience and not have any immediate feedback, but I hope it worked well for you guys.
Thank you, Trevor. At this time, I'd like to open it up to questions, and you can send your questions across the box on the left-hand side. I've just initiated a question to everybody as far as if you have any questions, and then also Trevor's email. Has this been helpful to you all? I'm waiting for responses. So I'm hoping that somebody's going to put something in that little box and send it.
Somebody put a check up there. Happy.
A hand is raised. Okay, Charlotte, if you can type in, that's the only privilege you have, is that you need to type in. Greg, I'm hoping you're saying you're checking it because you think it's been helpful. Actually, let's do that real quick. We can use in the top left-hand side, there's boxes, and you can see some of the people are, they click on their name, and then they can go down and use a green check for yes or an X for no. If this has been helpful, can you check, please? And we'll just do a quick polling. And if you're not checking, can you share with us if it's something else that you need, at least for the beginning of this? Yeah, I'm getting Charlotte's comment that knowing that it's recorded for future reference. We really like that idea also. We realized that the notice to attend this was very quick, and agent schedules are just crazy, and the ability to have it recorded and being put up on the website for later use, we really like that. So hopefully that's a nice option for you. PowerPoints are available. As a matter of fact, Wick, when we started this presentation, we let everybody know, hopefully in all of the counties there should be a hard notebook, a 3-ring notebook, and also a jump drive with all the electronic files. And in addition to that, the website that I took you through on the agents only portion of it, it will have all of the files, all of the PowerPoints and the references. So Wick, you just need to look at that book, buddy. Let's see, Jan is asking, Trevor, if you can estimate a time when GAP will become mandatory to the industry. I'll let you take that, Trevor.
I think, and Diane, feel free to jump in, but the stuff that's going through the Congress right now, I think some form will pass in that it'll probably take 2 or 3 years actually for that to get into place. So I'd say, do you guys have a different?
Trevor, you're cutting out, so I didn't get a full acknowledgement of time. Do you want to try that one more time?
Yeah, I guess I would say probably with stuff going through the Congress right now, it'll probably take about a year for that to get sorted out, and then about 2 to 3 years before it's implemented. So I'd say probably some 3-year time range. And again, do you, Diane?
Okay, you're again cutting out, and so I'm going to take that lead and let Chris comment too. I think that we might see portions of the gaps looking at maybe the traceability portion. We always thought the traceability portion of gaps would be coming down the tubes a little quicker than anything else. So they might decide to actually take that portion out of anything else that's getting passed and move that along a little quicker. As some of you may know, there is a House bill that was passed, and there is the Senate bill that now that the health reform is up on the docket and looking at getting passed, we imagine that food safety will be on the docket next. And so I think, probably 2-3 years will be an option that is likely. Chris, do you want to comment on that?
I think you said exactly what I was going to say. Now that the healthcare reform is being taken out of the mix or has been pushed forward, the next issue will be safety-related bill that's in the Senate. I think, like Trevor mentioned, it's going to be a couple of years before it actually rolls out, or we actually know how that will impact the industry, but it's definitely coming.
Great, thanks. Okay, so now back to Wick's question as far as leeway for small growers. That's a very good question. There's the term exempt is being thrown around. And so the best I can do as far as acknowledging that there's some action in the hopper, there's discussions. The North Carolina Fresh Produce Safety Task Force has a working group 3 that are very active. The working group 3 is mainly, it's led by Debbie Hamrick from the North Carolina Farm Bureau and is made primarily up of growers. And Antonio, who's on the phone or on the webinar right now, is one of those growers. They are very active in talking to legislators and trying to get at least the acknowledgement that one size does not fit all, and make some recommendations that would allow small farmers to continue forward without any significant economic hardships that maybe some of this would cause. Currently in the House bill they have a registration fee of food handling facilities, so that would be anything that's repacked, $500 annual dollars. So that might adversely affect our small growers.
To add to that,
oh, go ahead, Keith.
Traditionally with other, and I think this one will probably play out.
Trevor, can you try to move your mic closer to your mouth? Maybe you're really cutting out. I'm not sure.
I can try. I think it's one more than problems, but in the past they actually gave, like, big companies had to be HACCP certified by a certain date, and then the small companies had to be certified by 6 to a year later, and then the really tiny guys had like 2 or 3 years to get things in place.
Okay, so let's see. Did that capture some of those questions? Antonio is asking, will this presentation be available only to agents, or can growers access as well? Currently, the system that we have set up, Antonio, is that it is a train the trainer. So we are envisioning that growers that are in need of this could go through their extension agents at the county level to get this information. If there's a problem, if there's a need, we will work with that grower and with the extension agent to facilitate the need as best we can. Charlotte asked, what was the dollar amount you mentioned? Sound is cutting off. Let's see, I don't remember what that was. Anybody can help me there? Okay, hopefully I'll remember here in just a minute. Jan?
I think it was, Diane, I think it was dollar amounts where the cutoff for the processor or hand.
Oh. Okay. I think in reference to the House bill, there was a $500 annual registration fee of processing facilities. Jan McGuinn is asking, can you share with us also the farmers markets that are requiring gaps? I think generally, Jan, what we're hearing from out in the county level is that many of the farmers markets and in their bylaws, they're requesting that their vendors have some food safety training, maybe not get to the point of GAP certification, but the food safety training. Thus, the reason that we've created this tiered educational program so that it can give us that again, we're not looking for that one-size-fit-all. It will give us the level that the growers need to fit their particular markets. And again, the envisionment is that everybody could obtain at least Tier 1, and if not, if not more, the rest of those tiers. I hope that captures the questions so far. Any further questions or any further comments from Trevor and Chris? And we probably need to tie this up because we're over time. Okay, at this point, I'd like to go ahead and conclude our first session. If you have further questions, you can reach any one of us via email, and we look forward to seeing you at the next Illuminate session scheduled on the 17th. Take care.